Hey everyone. Okay, so this is day 2 of this section, and today we're going to talk about cube root functions. So if you think about what we've covered so far, we spent an entire unit talking about how to graph x squared. Yesterday we talked about how to graph the square root of x. Today we're going to talk about how to graph the cube root of x. Okay? In each of these functions, we talked about finding the critical point, or the vertex if you're talking about a quadratic, and then from that point, evaluating. So for instance, if this was my point for a quadratic, I would move right 1 and square it, and right 2 and square it, and right 3 and square it. And then I would plot my other points because of symmetry, and I would get something that looked like that. If I were talking about a square root function, let's say this was my critical point, I would go right 1 and square root it, and right 2, and right 4 and square root it, and right 9 and square root it, and then that would be my function. Okay, so I'm going to erase these. Alright, so we're going to do the same thing today. We're just going to do a different operation. So instead of square root or squaring, we're going to cube root. Okay, but in order to get there, let's make sure that we can do the warm-up problems. I would start each of these by identifying the critical point. Okay, so since there's nothing inside the parentheses that's not moving left or right, since there's nothing outside, it's not moving up or down, so then your critical point would be 0, 0. From here, remember we want to think about specific numbers we want to take the square root of, so perfect squares. Square root of 1 is 1, so up 1. Square root of 4 is 2, so right 4 up 2. Square root of 9 is 3. And you should have got a lot of practice of that within your homework. Okay. Next one. There's nothing under the radical, so 0 left or right. There's nothing outside, so again, 0. So I'm still at my origin. The difference with this one is the 3. So I'm going to perform the square root. I'm going to move, perform the square root, and triple my answer. Okay, so right 1, the square root of that is 1, times 3 moves me up 3. You can see I moved up 3 times as much. I move right 4. The square root of 4 is 2, times 3 is 6. I move right 9. The square root of that is 3, times 3 is 9. Okay, so you can see from the first graph to this graph, stretched by 3. Okay. In the next one, positive 4 means that I've moved left 4, and then the 6 means up 6. Okay, I need to pay attention to the fact that this is negative, which means it's reflecting. So I plot my point at negative 4, 6. Alright, and then right 1, the square root of that is 1, but then I go down 1 since it's negative. I go right 4, the square root of that is 2, so now I go down 2. And then I move right, I've moved right 1 and 4, I move right 9, square root of that is 3, so I go down 3. And then I go right 16, but that's not going to fit, so then this is my function. Okay, my first function was only increasing, my second function was only increasing, and my last function is only decreasing since I reflected it. Okay. Alright, so that's review of your square root functions. Let's talk about what a cube root function looks like. So this is your cube root function. I want you to evaluate your cube root function for these x values. Alright, so I want you to get your calculator out. In order to do the cube root, you can hit your math button and go down to number 4 where it says cube root. And we're going to take the cube root of negative 8. Notice that we actually get an answer of negative 2, whereas yesterday we did not get an answer. It said invalid. Cube root means what times itself 3 times gives you that number. Okay, so think about a square root. If I did the square root of 25, it's saying what times itself twice gives you 25. Well, 5 times itself gives you 25. Cube root is saying what times itself 3 times gives you negative 8. So if I'm doing the cube root of negative 8, the reason it's negative 2 is because negative 2 times negative 2 times negative 2, notice the 3 times, gives me negative 8. So when I take the cube root of -1, I'm saying what times itself 3 times gives me -1. Well, that would be -1. Or I can check it in the calculator. Oops. The cube root of -1 is -1. The cube root of 0 is 0, since 0 times 0 times 0 is 0. The cube root of 1 is 1, since 1 times 1 times 1 is 1. The cube root of 4 is not a nice number. So this is just to illustrate that this is not a number, 1.59. This is not a number that we're going to want to graph. So we're actually going to ignore that number. And then the cube root of 8 is 2, because 2 times 2 times 2 is 8. Right? So if I graph this, I get -8, -2, -1, -1, 0, 0 is my critical point, 1, 1, and 8, 2. So you can see there's not very many points that lie on this graph. And then that's my function. It goes up very slowly, but this will continue to go up, and it goes down very slowly, but this will continue to go down. Okay, we really don't care about any other x values than that, because if I were to do 3 times 3 times 3, I would get 27. So the cube root of 27 is 3, but I can't move 27. Okay. The nice part about cube root functions are their domain, range, and where they increase and decrease. Since this goes all the way left and right, my domain is -infinity to infinity. This goes all the way down, and this goes all the way up, reaching everything, so -infinity to positive infinity. This function from left to right goes up, 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 up forever. So it never decreases, and it increases over its entire domain. So the nice thing about cube root functions is you'll always be -infinity to infinity. It just is a matter of whether it's increasing or decreasing. Okay. So what's the pattern for a cube root function? It's going to be, again, yesterday was what do I want to take the square root of to get nice numbers? This one is what do I want to take the cube root of to get nice numbers? Well, I want to take the cube root of 1. I want to take the cube root of 8. And then that's it. And then in terms of negatives, I want to take the cube root of -1. And I want to take the cube root of -8. So if I take the cube root of 1, I get 1. Cube root of 8, I get 2. Cube root of -1, I get -1, and the cube root of -8, I get -2. So these are my inputs, or my left and right movement, and these are my outputs, or my up and down movement. Alright, and we'll practice that in a bunch of problems. Alright, so we get to do the same thing that we did yesterday, just with a cube root function. So has this been shifted left or right? There's nothing under the cube root, so no. Has it been shifted up or down? Yes. That's a +6, so up 6. So my critical point, underneath the radical there's nothing, or the cube root there's nothing, so 0. And on the outside there's a 6. Okay. Has it been reflected? No, because my a value is positive. This is a positive 1. Has it been stretched? No, because my a value is 1. So a value 1 not stretched. Stretched is anything other than 1. So 1.5, 2, 1.6, -2.3. Something like that. Okay. My domain and range and increasing and decreasing are a lot easier to answer once I have a graph. So I'm going to graph it first. If I graph the coordinate 0, 6, I'm here. Okay, and then once I'm here, I want to think again about what numbers are nice numbers to take cube roots of. So from here, if I go right 1, the cube root of 1 is 1. The cube root of 8, all the way over here, is 2. Notice I'm skipping a lot of numbers for cube roots. Alright, now unlike a square root, though, I want to go backwards. So the cube root of -1 is -1, and the cube root of -8 is -2. Kind of like a quadratic, there's symmetry, or not necessarily symmetry, but there's a pattern to it. Notice right 1, up 1, left 1, down 1. Notice right 8, up 2. Notice left 8, down 2. So that can kind of help graph too. Okay, if I connect the points, this is what I get, going up and going down. So it helps me in terms of domain. I can see that this is going to reach all the way left and all the way right. so negative infinity to positive infinity. I can see that this is going to reach all the way down, and this is going to reach all the way up. So negative infinity to positive infinity for my range. This function is never decreasing from left to right. It's only going up, and it's increasing over its entire domain. So negative infinity to positive infinity. Okay, again, that's the nice part about the cube root is the negative infinity to infinity. You don't have to worry about a stopping point, or like we did with square root and quadratics. All right, flip over to the back page. This would be a good point for you to try number 2 on your own. Okay, since all we're doing is really just changing the critical point. So good place to pause, and then you can come back and check your answer. Okay. Okay, assuming that you are now checking your answer, let's see. Has it been shifted left or right? The -2 means I move right 2. The -4 means I move down 4. Opposite of -2 is +2. And then -4. Has it been reflected? No, because my a value right here is 1. Has it been stretched? No, since my a value is 1. Okay, so if I graph the point 2, -4, I'm here. When I graph, I'm graphing 1 times the cube root of x, and that 1 doesn't do anything, so all I'm doing is moving and cube rooting. I move right 1, the cube root is 1. The next number that I want to take the cube root of is 8, so if I move right 8, cube root of 8 is 2. Alright, again, unlike a square root, I need to go backwards. So since I went right 1, up 1, I'm going to go left 1, down 1. Since I went right 8, up 2, I'm going to go left 8, 2, 3, 4, 5, 6, 7, 8, down 2. So 2, 7, 8, down 2. Okay? Remember, you're always going from your critical point in terms of moving. You're not going from the origin, unless your critical point is the origin. Alright, domain, I go all the way left and all the way right. Range, I go all the way down and all the way up. This function is never decreasing, so that means it's increasing over its entire domain. There we go. Alright. Now the next one is pretty similar, but we're actually going to stretch it. So has it been moved left to right? No, because there's nothing under the radical. Another way that you can think about this being written, which we won't write it as, but you can think about it, is 2 times the cube root of x minus 0, since there's no number under there, plus 0, since there's no number out there, and that kind of shows you why the critical point is 0, 0, and why it hasn't been shifted up or down, or left or right. Has it been reflected? No, because the a value is positive. Has it been stretched? Yes, by a factor of 2, since my a value is 2. Alright, so if I graph it, my critical point is here. I'm graphing 2 times the cube root of x. So that means I want to move right or left, cube root it, and multiply it by 2. Alright, so if I move right 1, the cube root of that is 1, times 2 moves me up 2. And then the next thing, I want to skip 2 and 3 and 4 and go all the way to 8. The cube root of 8 is 2, times 2 is 4. Okay, and then knowing that right and left are opposite, if I move right 1 and up 2, I'm going to move left 1 and down 2. And if I move right 8 and up 4, I'm going to move left 8 and down 4. And then here's my function. Stretched by a factor of 2. Domain, literally these are the same answers as my last two problems. It goes all the way left and right, all the way down and up. It's never decreasing, it's only increasing. So you should be kind of putting together right now that the only way that it can switch from increasing to decreasing is if I were to make this a value negative, and then it would go something like this and get reflected. Okay, I'm going to take this off though. Alright. Now let's try one that we reflect. So, I'm going to skip to my critical point because we should start to be able to kind of recognize this. My critical point, opposite of 3 is -3, -5. So, I graph -3, -5. -3, -5 is here. Okay. Has it been reflected? Yes. So now I should be thinking that I'm going down instead of up, or up instead of down. Has it been stretched? No, because my a value is still 1. It just happens to be a negative 1. So when I graph, I'm thinking negative 1 times the cube root of x. So I still move and take the cube root, but now instead of multiplying by 2 like I did in the last problem, I'm going to multiply by negative 1. Okay. So from this point, if I move right 1, the cube root of that is 1, but instead of going up, I'm going to go down. Notice I'm going the opposite. Next thing I want to do is move 8 from here. And once I move 8, the cube root of 8 is 2, times negative 1 is negative 2, which is why I want to go down 2. Okay? That's all I'm going to be able to fit there, because the next thing I'd have to go right is 27, which won't fit. So, if I moved right 1 and down 1, now I'm going to move left 1 and up 1, so I'm going the opposite. If I moved right 8 and down 2, now I'm going to move left 8, which doesn't really fit, but I'm going to do it anyways just to kind of help me. The only problem with not plotting this point, so if I move left 8 and up 2, I'm right here. You don't need that point since it falls off your graph. But what I see a lot of times is when people don't have this graph here, they go like this and graph this right, and then they do this, and all of a sudden it becomes really up high, and that's not what a cube root does. So by having this point here, it kind of shows us that it's really slowly increasing or decreasing. Okay, so that's what it should look like. Very slowly going down and going up, not something that, like, I always see things that go like this. Okay, so domain, even though I've reflected it, is still going all the way left, all the way right. Range is still going all the way down and all the way up. It's just the left and the right flip-flopped. This function is now never increasing, and it is only decreasing over its entire domain of negative infinity to positive infinity. So same answers, except increasing and decreasing and flip-flopped. All right. Last one, this would be a really good time for you guys to pause and try it on your own, and then come back and make sure that you kind of understand everything, since we've just done 4 examples together. Okay, so assuming that you are checking your answers, let's see how you did. Your critical point should be at 1, 6. Has it been reflected? Yes, because your a value is negative. Has it been stretched? Yes, by a factor of 3, since you have a 3. When you graph, you're going to want to be thinking of negative 3 times the cube root of x. So we're going to move right or left, take the cube root of it, multiply by negative 3. All right. If I graph the coordinate 1, 6, I'm here. If I move right 1, the cube root of that is 1. Times negative 3, though, moves me down 1, 2, 3. From here, I can go right 8, which is me here. Cube root of 8 is 2. Times negative 3 is negative 6. So I land on my x-axis. Alright, from here I can kind of use symmetry or my pattern to see what's going on. Right 1, down 3 means I would move left 1, up 3. And then my next point's not going to fit. But again, you want to be very careful. So a lot of times what I see is that people do this and graph a function that looks like that, which is not right. I also see things that look like this, where we understand that that's slow, but then this still goes up really far. Okay, just remember what this looks like. A cube root function looks like kind of like an S, something like that. So even though this is stretched by a factor of 3, it's still going to go through here, and it's not going to increase or decrease very fast. It's going to be slow. And then once it gets to here, it's going to level out this way as well. So it goes like that. Okay. Domain range increasing, decreasing. So all the way left, all the way right, all the way down, all the way up. It's never increasing from left to right. I'm only going down. So negative infinity to positive infinity. All right. So in terms of graphing and domain range increasing, decreasing, it should go a little quicker. But again, you want to think about what numbers do you want to take the cube root of. Sorry, it's my dog. Come on, Bogey. So you want to take the cube root of 1. You want to take the cube root. Okay. 8. Moving left 1 and moving left 8. So a lot less numbers to have to worry about than a square root. Okay? Your homework is worksheet number 2. It will have a mixture of cube roots and square roots. So I want to point that out because a lot of times I've seen you guys just jump right into assuming that everything is cube root. Notice that this is a square root. So your function should look something like this. Whereas a cube root, if this is your critical point, your function would look something like this. So notice cube root. Notice cube root. Okay. Cube root, square root. Alright, so just pay attention to what operation is actually happening. Alright, and then the only thing that we can really change is the critical point, the a value, and whether it reflects or not. And then it's just a bunch of practice of the same thing. Alright, and then tomorrow we will talk about absolute value, and that will be your last function. Alright, thanks guys, have a good day. If you have any questions, come see me tomorrow morning.